Number 23. Nitrosyl chloride, which is NOCl, decomposes to NO and Cl2 as per this balanced equation, right? 2 NOCl gas, which will yield or decompose into 2 NO gas plus the Cl2 gas. Determine the rate law, the rate constant, and the overall order for this reaction from the following data. And they give us a beautiful chart. Now, in this case, this chart, right, we have concentrations of NOCl, right, and that's the initial reactant, nitrosyl chloride. And from those concentrations, out comes a rate. So it tells us basically about how fast the NOCl is decomposing. And as we can see here, right, as we are increasing our concentration, right, from 0.1 to 0.2 to 0.3, what's happening to our rate? Is it increasing or is it decreasing? Yeah, it's increasing, right? From 8 times 10 to the negative 10th to something that's 10 to the negative 9th. So we see a trend here, that the general trend that if you increase a concentration, the rate of the reaction is going to increase. But now we just need to find out that specific rate law. But when they give you a chart, right, this is a very standardized type of question. You might see it on your test or quiz, but if they give you a chart, especially the golden number is 3 trials. Sometimes they might give you 4, but if they give you 3 trials and they're asking for the overall, the rate law, what they're secretly asking you is to find the order. You're trying to find those orders of the reaction. But now, what does it mean by orders? Well, if we look at the general rate law formula, which is this right here, right? Any type of general rate law is always rate equals K, and the K is the rate constant. And it's times by the concentration of the reactants. And in this case, we only have that one reactant, the NOCl. That's why in this chart, you only care about the concentration of NOCl. Nobody cares about NO and Cl2 because those are products. So nobody cares. It's always the concentration of the reactants, but here's that order. We want to find out the orders. So this is essentially the exponents. But now how do we do that? Well, we have to make a ratio. So we make a ratio by putting one rate law from one trial divided by the rate law for another trial. Now in this case, I'm just going to list them out as saying that maybe this one, we have a first trial, we have a second trial, and we have a third trial, right? These are all experiments just to see, if the rate changes with changes in concentration. If you want to call it an experiment, that's fine with me as well. But essentially what we have to do is we have to pick 2 trials and we have to just put one over the other. Now, in order to make everything nice for us, I find that the easiest way to go about this is to always set a higher rate value and divide it by a lower rate value. If you do this, the numbers that you're going to be working with at the end of the day are going to be greater than 1, and you're not going to be dealing with fractions. So it might be easier to find out your answer by just doing it this way. Now, it doesn't matter which trial we use in this case because we only have one reactant. I just have to pick a higher rate over a lower rate. Now, if you want to try out a different choice than I did, we technically should get the same answer at the end of the day. So, for me, I noticed that 10 to the negative 9th is a greater exponent than 10 to the negative 10th. So, what I'll do for this video is maybe I'll put trial 2 over trial 1. So that's what I'm going to do. So we'll do trial 2. So trial 2 divided by trial 1. What was that? Divided by trial 1. Now, there's other options that you could do. If you want to, you could do 3 divided by 2. They have the same exponent, So you look at the actual numbers now. 7 is greater than 3. So 7.2 is greater than 3.2. So you could have did trial 3 over trial 2, or you could do trial 3 over trial 1. And let's see if the answers are the exact same at the end. So now I'm going to put in all my trial 2 numbers into this generalized rate law. So the first thing is the rate. Well, I know that. 3.2 times 10 to the negative 9th equals the K value. And we're going to times that by the reactants. And the reactant for trial 2 is 0.20. Now, I know I kind of just skipped right over the K value. I should elaborate on this. They didn't give us a rate constant. And after we find the rate law, we are going to find the rate constant. So since I don't know it right now, I'm just going to leave it as K. Hopefully it works out in the end. And we're trying to find those orders. So you could use any variable that you want. Generally, we use X. So X it is. Whoop. What's my dog doing? I don't know. He's having a good day. Anyway, trial 1, the rate is 8.0 times 10 to the negative 10th equals, I still don't know that rate constant, so K, times it by the 0.10, and that's raised to the same exponent because it's the same reactant. So if I label this as X, I'm going to label this as X as well. And now all it is just simplifying, right? And look here, guys. K divided by K. Technically, it's going to be a constant number, and it's the same variable. So even though I don't know it, bye-bye. Don't care. So now we just clean it up, do the math, right? 3.2 times 10 to the negative 9th divided by 8.0 times 10 to the negative 10th. This is going to be 4, it looks like, but we could always just, try it out in our calci. 3.2 times 10 to the negative 9th divided by 8.0 times 10 to the negative 10th. If you're doing exponents, times 10 to the, make sure that you use the EE button because then the calci understands to group those numbers together and you won't have to worry about using parentheses. And there it is. So this equals 4. And this equals, maybe I'll put a green over there just to kind of put them together. And now what you're going to do is you're going to do this, right? 0.2 divided by 0.1. That's going to be equal to 2. But once again, since we have calci, I feel like I just got to show it. There we go. And we simplify it. Since they have the same exponent, that's why we can divide. And we get now that. So now we say 2 to the what will get me 4. How many 2's do I have to multiply to get to 4? And you're absolutely correct. X equals 2. So, right? Because 2 times 2, I have 2 of these. 2 times 2 is 4. Okay. So, we found out the order, right? X equals 2. That is the order. So now we go back to what the question was actually asking for. What was the rate law? So maybe what I'll do is I'll just raise this up a notch. Because now the only thing that we care about is plugging in that number for the rate law and putting in the more specific reactant. But it would be just rate equals. We don't put in any values for that because it could change. Rate equals K times the concentration of that reactant, and the reactant is the NOCl, right? And it was right here. That's who we took, so it has to be NOCl. And it is raised by the order of 2. And that is the answer to the first part. So do you see how, by just finding out that order, we found out the rate law? So this is check. Now we use that piece of information to get to the next point. We want to find now the rate constant. So find the rate constant. And remember, the rate constant is the K value. Now in this case, it doesn't really necessarily matter which trial you use to find the rate constant. Generally, if you use each one of them, you should get roughly about the same rate constant. But each professor, each teacher is different. Some teachers would make you want to find each K value for every trial and then take the average. Some teachers I see always use the last one, but I mean, technically it doesn't really matter. So in this case, since I use trial 1 and 2 to find out my rate law, let's just use trial 3 to find out the rate constant. You could have picked trial 1 or trial 2 and see if we get the same numbers, right? So now we know the general rate law, right? The general rate law, if I just copy this, is this guy. And now we just plug in trial 3 values to solve for K. So let's see, the rate is 7.2 times 10 to the negative 9th equals a K value. And this is going to be times by that concentration for trial 3, 0.30, and that's raised to the second. So now we're just going to do some math. We'll do 0.3 raised to the second. So we get 7.2 times 10 to the negative 9th equals, I'll just put that number in the front there because it's all being multiplied, 0.09 times K. And now just divide by the 0.09 on both sides, and you shall get your K value. So 7.2 times 10 to the negative 9 divided by this answer. And that looks good to me. There we go. So we get 8. And I guess looks like all 2 sig figs, so we'll say 8.0 times 10 to the negative 8th. Now, the tricky part with K values is that we need to find the right units. Now, generally speaking, there is a trend for the units of K. So maybe what I'll do is I'll just maybe put up here the secret units for a K value given your overall order. So maybe what we'll do is we'll find out the overall order first, and then we'll go back and fill in the units of the K. Now, you can always find the units of the K if you want by using the same rate formula and plugging in the units and solving. I think it's a little bit easier to just kind of memorize your K values with your overall orders. So what I'm going to do is we're just going to find out the overall order over here. Now the overall order, literally overall, is the sum. All we have to do is just add up all the orders that were given. But in this case, since we only have one reactant, and that overall, and that order was the second order, there's nothing to add here. So in this case, the overall order is 2. So that was pretty easy. And then we're going to use those units to kind of find out the units for K. So I'll put that up here now. So we'll go up to number 2. So if you have a overall order, maybe what I'll do is I'll say overall order, and then I'll say units of K. Okay. Now this is all going by, if I did plug in the units and solve for the K, this is what you would get out. So if you have an overall order of 0, your units of K is always going to mimic the units of the rate. So literally, whatever the rate units are, that's what the units of K are. But we can't use that because we're in second order. Now, if you have an overall order of 1, the units of K is always going to be 1 divided by what the time was. So in this case, they gave you the time in hours. So in this case, it would be 1 over hour. But we don't have that because it's the second order. So now this is ours. If you have an overall order of 2, the units are going to be 1 over molarity times the time. Now there's a lot of different ways to write this out. So you can use it 1 over molarity times hour. You can do the flip of saying liter mole to the -1, but generally all those units are the same. I like to just go for the molarity. You could also say that it's molarity minus 1, because it's 1 over molarity, and then just put that time. The time that they gave us was hour. I say HR, they say H, doesn't really matter, but that's the units for K. And that is the final answer. So just make sure that when you're finding out the rate constant units, just make sure that you have the appropriate units. So maybe what I'll do is I can get rid of this and say m to the -1, t to the -1. This would also be 1 over time is the same thing as time to the -1. Your time is always going to be in the denominator. I hope this helped. Let me know in the comments. Thank you so much for viewing the video, and I look forward to helping you out. Subscribe to the channel to help us out. Thank you, thank you, thank you, and I'll talk to you soon, okay? I hope you have a great day out there, and you guys rock. All right, good luck on those tests and quizzes. I'll talk to you soon, okay? Bye-bye!